This section deals with solving exponential and logarithmic equations. Solving exponential and logarithmic equations, same concepts apply as when you're solving any other type of equation. You're trying to isolate the variable and get it by itself. So for something like this, if you were trying to solve for x, you would first subtract 9 to get the fourth root of x plus 2 is equal to 5. Then, to get rid of the fourth root, you would take it to the fourth power. And then you would have x plus 2 equals 5 to the fourth power, which is 625. And finally, the last thing you'd have to do to isolate the x is to subtract 2. So x is 623. Now then, when you're solving exponential and logarithmic equations, starting here with exponential type of equations, a couple of ways that this can be done. One is to write with the same base. Here we have a base of 2 and here we have a base of 8. Well, can we get both of them to be the same? Well, 8 can be changed because 8 as a base of 2 would be 2 to the third power. And then the x just stays there. So we replace the 8 with 2 to the third, and we leave 2 to the x plus 4. And then because we have the equal sign here, since the base is the same on both sides, the exponents must be the same also. So then x plus 4 is equal to 3x because you multiply exponents together. And now it's just a matter of solving for x by subtracting x. X 4x or 4 equals 2x, and then dividing by 2 to get x equals 2. So if you were to substitute a 2 in here to this equation, 2 plus 4 is 6, so 2 to the 6th power is the same as 8 to the 2nd. Now in this one here, 1 over 100 x minus to the x minus 2 equals 1,000 to the x plus 3. Can do the same thing. Difference being, in this first one, we only had to change the base of one of them. We took the 8 and made it 2 to the third. Well, here, you can't make the base 100 for both of them because 100 to some power to get to 1,000 isn't possible. But 1,000 can be written as 10 to the third power to the x plus 3. And 100 is the same as 10 to the second, but because this is 1 over 100, it would be 10 to the negative 2 power, and then x minus 2. Now they both have a base of 10, so then multiplying exponents, a negative 2x plus 4 is equal to 3x plus 3. Solving this for x, let's see, we will add 2x, subtract 3, and get 1 equals 5x, and then divide by 5, and x equals 1/5. All right. Moving on to our next problem. Same type of thing. 8 to the 5x equals 16 to the 3x plus 4. So let's see, 8 and 16. 8 can't raise it to a power to get to 16, but you can say 8 is 2 to the third to the 5x, and 16 is 2 to the fourth. to the 3x plus 4. And now because the bases are the same, 15x has to equal 12x plus 16. Subtract 12x, and you get 3x equals 16. And then you can divide by 3 to get x equals 16 thirds, or 5 1/3. Or if you must, 5.3 repeating. Now, the other way that you can solve an exponential equation is by using the inverse of an exponential, which is a logarithm. So with this particular problem, or any of the other ones, you can do a log to both sides. So for example, this problem here, because this is 8 and this is 16, it doesn't matter which side you choose. We're going to choose this side. We can, okay, let's write the problem first again. If we want to get rid of the 8, other than writing it as the same, with the same base, that's always a way that you can do this. You can get rid of the 8 by putting a log base 8 here and a log base 8 there. Now log base 8 of 8 is saying 8 to what power is equal to 8, and that is 1. And then by your properties of exponents, when you have a logarithm, that becomes the multiplier of it. So we would have 5x times log base 8 of 8. And like I said, log base 8 of 8 is 1, so this is just 5x. Now on this side, you have log base 8 of 16. This is where if you do not have a calculator that can enter that, then you have to do log 16 divided by log 8. Or you can use ln. So log 16 divided by log 8 is 1.3 repeating. And that as a fraction is 4/3. So we're going to write it as 4/3. And then you have 3x plus 4. If it wasn't something like 1.3 repeating, then you just use the decimal form of it. And so now you can distribute that. And 4/3 times 3x is 4x. And 4/3 times 4 is 16/3 equals 5x. And then you can subtract 4x, and x will be 16/3 again. The other way to do this, instead of taking log base 8 of both sides like we did over here, we could get rid of the 16 as our base first by doing log base 16 on both sides. And then log base 16 of 16 is 1, so the 3x plus 4 would be here. And then on this side, we'd have to do the other way. Log 16 divided by, or log 8 divided by log 16, which is 0.75 or 3/4 times 5x. And then 3/4 times 5 is 15 over 4x equals 3x plus 4. If you subtract 3x, you get 4. And let's see, 15 over 4 minus 3, which is 12 over 4. That would be 3 over 4x. And then multiply this by 4/3 and multiply this by 4/3, and x will equal 16/3. So that's the other option. Doesn't matter which side you use, you just log with whatever that base is. When you have problems like this one here, you could do that with this as well, but changing the base to 2 on this is probably the easier way to go. So we'll look at some problems where that's not an option. So solving exponential equations, here we have 10 to the x plus 4 equals 72. So to get this out of there, out of the exponent, we have to do log base 10. And remember, when there's a 10 here, you don't have to write the word or the number, so that we just log both sides. And then by your properties of exponents, or by your properties of logarithms, that becomes the multiplier of log 10, 10. And log 10, 10 is 1. So x plus 4 is equal to log 72. Now you could put this into your calculator at this point in time, or just wait until you're done at the end, because you should not round your answer, and then if you have to do more math later and you have to divide and you don't get a whole number again, you're going to have to round your answer a second time. So you should only round your answer one time in a problem, and that should be at the end. So when you put this in your calculator at this point in time, make sure you either use ANS or don't put it in your calculator yet and just leave this as an expression until the end, and then type in your final answer when you're all done. So now to solve for x here, we would subtract 4. And so then x equals log 72 minus 4. And if you type in log 72 on your calculator, that is 1.857332496. And when you subtract 4, you will get a negative 2.14266. So this would be x equals a negative 2.143 if we're going to 3 places. And then it's approximately equal to. All right, this one then says 5e to the 3x equals 120. So we can get rid of the 5 first. To have e to the 3x equals, and 120 divided by 5 is 24. Now how do you get rid of e? Well, the inverse of e would be ln both sides. Log with a base of e. ln and e go away, so you're left with 3x, and that equals ln of 24. And then finally, we divide by 3. So now you just type in ln 24 divided by 3, which is 1.059351277. Okay. So here's another one. 3 to the x plus 5 equals 7. So in this case, we have to get rid of the base of 3, so we're going to log base 3 this side and log base 3 this side. On the left-hand side, the log base 3 of 3, that's just 1, and remember that becomes the multiplier of 1 times x plus 5 is just x plus 5, and then you have log base 3 of 7, and if you have a newer calculator that you can type that in, you do so. If you do not have a calculator that you can type that in, then you have to do log of 7 divided by log of 3, or ln 7 divided by ln 3, either way. And then finally, subtract 5. And ln 7 divided by ln 3 is 1.7712434749. And then if you subtract 5, X is going to be approximately a negative 3.229 because it's 228756. So round to the 3 decimal places, or 3 places past the decimal would be 229. Now then, with a logarithmic equation like this, what do we notice we have on both sides of the equal sign? That's right, we have an ln and we have an ln. And just like back here, once you have the, let's see, we'll go back one. Once you have the bases here, the bases were the same, so then because the bases were the same and we have an equal sign in between, the exponents equal each other. Well, with this, those are the same, so that means 4x plus 1 equals 2x plus 5. And then you just solve this. So subtract 2x, subtract 1, and 2x equals 4. And then divide by 2, and x is equal to 2. Now, with a logarithm, when you remember it is the inverse of an exponential, and a logarithm on a graph looks like this. And the domain for a logarithm is x has to be greater than 0. Okay, so that means this value has to be bigger than 0. That value has to be bigger than 0. So when you solve a logarithmic equation, when you get a solution, you need to make sure that you check that solution to see that whatever is here is greater than 0. Well, if you substitute a 2 into that, 4 times 2 is 8 plus 1 is 9. 9 is greater than 0. And on this side, if you put a 2 there, 2 times 2 is 4, plus 5 is 9, which is greater than 0. And so that would work. Now, when wouldn't it work? Well, let's say this would have been 2x minus 5. So then that's a minus there, and a negative 5 and a negative 1 would turn this into a negative 6. And then when you divide by 2, you'd get a negative 3. Just because you get a negative answer doesn't necessarily mean that it doesn't work. You have to put it in, substitute it into this equation to see if you get a negative number there. So if you substitute a negative 3 in here, well, 4 times a negative 3 is negative 12, plus 1 is a negative 11. And if you try to do ln of a negative 11, your calculator is going to give you some imaginary solution. Or it's going to say not found. So therefore, this is not possible to do with real solutions. So you would say that that doesn't work then. All right. So when you have both logarithms and they're the same on both sides, you just, because they're the same, you can get rid of them. If this would have been log base 7 and this would have been log base 7, well, then it's the same thing. Fairly certain you won't get a problem where this is a 5 and that one's a 7. That's for a different time. All right, now this one, log base 5 of x plus 2 equals 2. Well, remember, in a logarithm, there's your base. That is your exponent. And x plus 2 is what it equals. So when you have a logarithmic equation with some base, remember that's the base, that's the exponent, that's what it equals. You just rewrite it like that. Or the other way to think about it is, okay, since it's log base 5, we need to have a base of 5, and we need to have a base of 5, and so 5 and log 5 are inverses of each other, and they go away. And then 5 to the second equals 5 to the, and then x plus 2 equals 5 to the second. So now 5 to the second is 25. X plus 2, subtract 2, and x equals 23. And again, you should check, make sure that this number then doesn't turn into something 0 or less. And if you put a 23 in there, that's 25, and yes, that works. All right, so here we have ln of 2x plus 1 equals 3. Well, when you see ln, what's your base? It is e. So e to the third equals 2x plus 1. And then we solve this by subtracting 1 and get 2x equals e to the third minus 1. And then we divide by 2. And then you have to use your calculator to figure this all out. So e to the third is 20.08553692 minus 1, which is 19 point all of that, divided by 2 then is, so x equals 9.543. All right, so in this one, 2 log x plus 1 equals 6. Hey, we can get rid of the 2 first by dividing by 2. So then we have log to the x plus 1 equals 3. And what's our base in this case? When you don't see a number there, it is 10. So 10 to the third equals x plus 1. And 10 to the third is 1,000. And subtract 1. So x is equal to 999. And that, I do believe, is everything that you will see in solving exponential and logarithmic equations.